Here's the square root of 48, and we'd like to write it in something called simplest radical form. What we're looking for are perfect squares that go into 48. We know that 4 times 12 is 48, but we also know that 16 times 3 is 48. So we're looking for the largest perfect square, so we'll take 16. And we're going to rewrite the 48 as 16 times 3. And then it turns out we can break it up as shown. The square root of 16 times the square root of 3 is equal to the square root of 48. But the square root of 16 is 4. So we write it as 4 times the square root of 3, often pronounced 4 root 3. And that brings us to the square root of a product property. The square root of a product of two non-negative numbers equals the product of the square roots of the two numbers. That is, for non-negative numbers x and y, the square root of the product of x and y is equal to the square root of x times the square root of y. Here's another example. The square root of 540. 4 goes into 540. 9 goes into 540. They're both perfect squares. But 4 times 9 is 36, also a perfect square. So 36 goes into 540 15 times. So we write it as shown, then as shown, and the square root of 36 is 6. So our simplest radical form is 6 root 15. Here's an interesting problem. It's the square root of 6 times the square root of 15. Neither one can be put in any form simpler than they already are when they're by themselves. But if we multiply root 6 times root 15, we get root 90. There is a perfect square that goes into 90, and that's 9. So we break it down again, and the square root of 9 is 3. So our final simplest radical form for root 6 times root 15 is 3 root 10. Now here's an addition problem, but every one of those terms contains a root 2. It's just as if they're variables. If it was 3n plus 4n minus n plus 3n, we'd get 9n. But in this case, it's 9 root 2. Here's one with 4 terms. 2 of the terms are root 2, and 2 of the terms are root 3. So just like if it was 2 variables, such as a and b, we combine the like terms. Well, 3 root 2 minus 5 root 2 is negative 2 root 2, and 2 root 3 plus 8 root 3 is 10 root 3. So negative 2 root 2 plus 10 root 3 is a much simpler way to write the original expression. Here's root 48 plus root 18 plus root 27. First, let's write each one in simplest radical form. We've already done the 48. 18 is 9 times 2, and 27 is 9 times 3. So the square root of 16 is 4, and the square root of 9 in the final two terms is 3 in each case. And now we have 3 terms, and 2 of the terms contain a root 3. So the 4 root 3 plus the 3 root 3 is 7 root 3. We recopy the 3 root 2, and we get 7 root 3 plus 3 root 2. Here's one even more complicated. 2 root 27 plus 3 root 75. Take away 8 root 45. We simplify each one of the square roots. And a 27 is 9 times 3. 75 is 25 times 3. And 45 is 9 times 5. So the square root of 9 is 3. We bring it out, and now it's going to be 2 times 3 times root 3. The square root of 25 from the middle term is 5. We bring it out to get 3 times 5 times root 3. And in the final term, the square root of 9 is 3. So we have 8 times 3 times root 5. We do each one of those products to get 6 root 3 plus 15 root 3 minus 24 root 5. We combine the two terms that contain root 3. We get 21 root 3 minus 24 root 5. And we've simplified it as much as we can. When simplifying radical expressions, use the square root of a product property to put each term in simple radical form. Then combine like terms. And once again, the square root of a product property states that the square root of the product of two non-negative numbers is equal to the product of the square roots of the two numbers. That is, for non-negative numbers x and y, the square root of the product of x and y is equal to the square root of x times the square root of y.